Good morning, everyone.
Hello.
Thank you for joining us for today's session about progressive web apps. We think that you made the right choice by joining us today because we are going to show you really how to build a progressive web app and how, in some cases, building a progressive web app can be the smartest choice rather than building native mobile app. So during this session, we are going to talk to you about how a progressive web app might be a right choice in some cases, and we are going to show you also the HTML capabilities that that are provided by our navigator and what we can do with web today. And after that, we're gonna take a 20 minutes break, and then we are going to show you with live coding how to build a progressive web app. So to start, I will start by presenting myself. My name is Fedi Salah. I am a full stack developer at Serli. On every day, I don't actually create progressive web app and do that every day. I'm a backend developer. I use Play, Scala, Node.js for on daily basis, and sometimes I find the time to check some cool technology like what you can do with the progressive web app, and I don't know, deploying code on cloud functions or testing some technologies like Firebase or stuff like that.
Hello, my name is Guillaume Soldera. As Fedi, I'm working at Serli. Serli, it's a French company near Poitiers. I don't know if you know. I make some cool stuff with many technologies as React, Play Framework or Scala. And I build a progressive web app which runs in production actually.
So let's start about. Let's say you had an idea about creating an app. So the first thing we highly recommend you to do before starting building your app is to, in some case, define your users. Who will use your application and how will they use it? Are they going to use a browser to access to your application, or are they going to access your application from their mobile device? For example, this chart will show us how people reach the web, and we see that people visits the web more on a mobile device than on a desktop. So the other thing that we highly recommend you to do is to imagine how your application will be used. What are the user's condition of your application? Is it gonna be at home with a Wi-Fi connection, or is it gonna be outside on the subway, or maybe for example, for wine tasting app, is it gonna be used in a cave where there is no good quality of service? So having that in mind may lead you to make good choices when you are going to make architectural decision.
In an agile project, you have the story mapping phase, and it is the right time to do this analysis about your users.
So let's imagine now that we did the first step and we conclude that most of our users, or all of our users, will use the app from their mobile device. The first question that may pop into our heads is, are we going to build a responsive website on a mobile? Is it efficient? Or are we going to actually build a native application? So for us, it's not the good timing for asking this question, since for starter, for the user, it's not that important which technology we use when we would like to build this kind of app. For him, if the app behaves exactly like the app that he used to use, it's an app for him. And for what does really interest him is the feature of the app. So let's focus first on behavior of the user on mobile devices, and then about the feature. Then we can ask ourselves this question. So we will see users and their mobile devices. For example, this pie chart shows us that the time that people spend a lot more time on their mobile apps than on a browser. The second bar chart will show us that around 50% of the app are installed and never used. The other bar chart will show us that people average 10 applications per day. It's not that much. For example, for me, I have like 30 applications on my smartphone, and I don't even use 10 every day. I use 2 or 3, my favorite app, and sometimes when I get a notification or something like that, I will visit the other app, but on daily basis, I use like my favorite apps. So Google had made also an announcement in 2015 that said that 25% of the application are never used, and 26% of the application are uninstalled after first use. If you have like a big form to fill or subscription form or something like that in your app, users are not that patient. They will not fill all the form and go to your app. If they see that they don't go straight to your app when they click on it, they will lose interest and they will uninstall it.
Or maybe the app is useless or crappy.
Yes. So now let's see how the developers of mobile app, how do they behave. Let's focus a bit about the evolution of the mobile app. As we see, like in May 2013, the size app did not go above 200 megabytes. Now we are talking about gigabytes. I know that 5 years ago, when I had a phone with 32 gigabyte memories, it was efficient for me. It was large enough to contain all of my apps. But today, we are talking about 265 gigabytes, and maybe in 10 years we will talk about terabytes and mobile maybe. So what we should learn from this chart is that the size of mobile application is increasing. So now, also when we see this chart, we can see that that at least around 20% of the application almost are both made for iOS and Android platform. It's not that common that it's not common for all the applications that you have both applications. So when you build an application, you will maybe target platforms, users on on one platform, but not users on other platform. Other than that, we did heard about hybrid technology. Hybrid technology is like building a container with native language and then running JavaScript on this container. On 2016, it seemed a good idea, but by the beginning of 2017, like we see here, it was abandoned because it presents a horrible user experience and a horrible performance. So what we can learn after this phase is that people spend a lot more time on their app comparing to web. More than 50% of the app are installed or never used. Mobile app size keeps increasing, and it's kind of hard to compete in the mobile market because all the good seats are taken. Now, it's not that easy to create a new app and make your user use your app and compete with existing app and reach the user you want to reach on the mobile market. So once we had an idea about how users behave on their mobile app, the second thing is the second thing that might be important for us is to concentrate on which feature do we want our application to provide to the users. The first feature, of course, is not an option that we provide our user a non-smooth application, because smoothness is very, very important.
It's mandatory.
Yes. Also, our application, it has to provide an easy access. In one click, you go to your application. You don't need to type an URL or something like that. So also, we want that our application to provide a mobile look and feel and mobile user experience. Users already their habits, so they kind of know how to use an app. For example, let's take the example of the swipe left. We know that the swipe left is what mainly does is like to go to the previous screen. So let's keep that in mind, and when we will develop an application, it has to provide this kind of feature. Other than that, when we talk about security, we want our application also to ask permission before using or interacting with phone sensors. It's pretty important. We know that, for example, for Android application, for previous version, not the latest version, before installing an application, we ask like a whole bunch of permission because before the user install the application, and sometimes people, when they see that the application will access contact and stuff, they just won't install it. But what we want is that our application will ask the permission when also it's needed. We want it also to interact with mobile sensors, and we want it also to be engaging with, for example, with the notification. So when the content our application evolve, we want our application to send a notification for the user to tell them that the content had evolved, and they will when they click on the notification, they can see the new content. So now, once we explored once we defined this feature, and once we know we had an idea about behavior of users on a mobile application, now we can actually ask the question, which technology should we use? Native web or hybrid? A hybrid, we can avoid this choice because we know that the experiments were not that made with hybrid languages were not fulfilling for the users. They did not provide a great user experience. So, is it gonna be native or web? Maybe when we see all the features that we are talked about, like notification, access to interact with mobile sensors, ask for permission and stuff like that, the obvious choice will be we will build a native application. But actually, we think that this choice is not that obvious because we did not explore exactly what we can do with web. And that's why Guillaume will introduce you progressive web apps.
So, what is a progressive web app? It's the question is often asked. And what is it an API? Is it a framework? Is it another JS lib? Or is it just an app with a progress bar? Nothing of that. In the first answer from the user point of view, user doesn't care. For him, is it a native app? Is it a web app? It must make no difference for him. It's just an app that he can use on his smartphone as any app. For developers and for us, progressive web app is not only service worker. It's a big part of it. It's true. We'll see later in this talk. But it's two development and UX approaches. You must mobile first focused at each step on your build. You use web technologies as HTML, JavaScript and CSS, but always mobile oriented. You use technologies to have an app with app-like behavior. Google has emitted this idea of progressive web app in 2015, I know, and they define 3 main keys. Your progressive web app must be fast, it must be reliable, and it must be engaging. First, your application must be fast. It's obvious, but on this graph we can see that the bounce rate increase in the same time that the page load. So if you want to your user stay on your app, improve your page load. But the fastness is not only the page load. It's about user interaction too. Try to have smooth interaction and avoid a janky scroll or a free screen or something like that. Nobody like that. Second point, your application must be reliable. If you want your user can come to your website, to your app, you must care about the internet speed. If you want to reach users all over the world, you must take that in consideration. Then your application must be work in offline mode too. It's obvious, but you have need a first connection to have the website. But if after this first load, if you have no internet connection, it doesn't matter. Your application must work like a charm. Third point, your application must be engaging. User must feel like an ordinary app. He can launch your application from the home screen. He has some notifications, and when the application is launched, it's launched in the full screen for an immersive experience. Everybody knows this notification, and everybody click on it. You click on it because you have a new tweet, there is a promo on Amazon, you have a new life on Candy Crush or something like that. And if you want your user come back on your application, make a notification. This re-engagement the key of your success. On this graph, we can see that the web can reach more users than native apps. For native apps, you must go to the store. You must find in the store the right application. When you find it, you allow all permission. You download it. You install it. Then you can use it. On the web, you search in your search engine. You find your answer, you click, and that's it. So in the same time, we can see that the native apps kept more attention than web app. It's due to notification. So progressive web app is a mix of these two worlds. And progressive web app has the benefits of the web. Users can find your web app on a search engine. And with HTML5 and browsers improvement, progressive web app has now capabilities almost the same that native apps. So, okay, now how build a progressive web app? What each step must I do? Google has at least many points to respect. First, your application must be responsive. Your application is on mobile, so if you want to have a well display, you must have a responsive application. But it's not only that, it's two UX considerations. Your user uses smartphone every day, so he has some behavior, he has some landmark, and be consistent with the guidelines of iOS or Android. For example, on iOS there is many applications with the same navigation. You have tab bar at the bottom of your screen and list item above. You click on the item, then you have the detail of this item, and in the other you have the back button. On iOS you have a floating action button or amber menu or something like that.
On Android,
Android, sorry. And try to reproduce this behavior. Your user don't know your application, but he must know how to use it. It has the same behavior as
an ordinary app.
Yes, and that the other app he uses every day. To this behavior and component as native behavior, you have just HTML. Do you know input that? On desktop, it's crappy and nobody uses it. Everybody prefer Bootstrap, that picker or something like that. On mobile, there is this input have a native behavior. It uses a native component to display the component. We can see on this picture on Android and on iOS. There is for input date, but it's for the all inputs too. You have the date time local input where you can choose the date or the time. The input email type. Input email, where you can see on the keyboard there is @ character. For the input tail you have the phone keyboard, and on the right you have the input file with accept image, I think, where you can take a new picture or browse your folders. In the same way, you can link to native apps with simply href HTML classic. On Android, you have the Geo protocol. It's the first line, and when you click on it, it launches an application which can handle maps, as Google Map or Waze or something like that. On iOS, there is a specific scheme, maps.apple.com, and it launches Plants application. You can launch the phone application too with tel or SMS protocol. On iOS, you can launch FaceTime too, if you want. And it's not right here, but obvious you have the Mail 2, which launch your email client. So it's free, so use it. We have prepared some samples to...
Yes, we have prepared a showcase. This is we can find the showcase on this URL or this shortened one, or you can scan the QR code. We show you the image, but it's better than to see proof with your own eyes. So let's show you some examples.
And you can play with it too, of course.
So
So
okay. This is some showcases we have. We are going to share the link on the slide after the slides after this presentation, so you can see the implementation behind this every link. So for native input, for example, when we click date, we see actually the native component, like Guillaume said earlier. So which is great. It does not work as well in web, but on mobile, it really uses the native component. Also for time picker, it does work also. I don't know, email, phone number, email with the phone number. We did phone number, chose file, browse or click on a camera. So that's it for inputs. We have also some other cool feature like I don't know, web share, for example. We can share a content. It actually uses the native API of sharing. We see the contact of Guillaume. It's a little bit private, so we won't share any content. So now we have actually other cool feature like multi-touch. I can drag and drop just. All this is just HTML and JavaScript. We can also do multiple drags with 2 fingers, like here.
And it works with the 3 fingers too.
It's not limited to 2 fingers. We can also one of the feature that I like more is speech recognition. We can actually dictate what we want to write in our application, and it just works. So here it asks us to say a color, but we will say, "Hello, Devoxx Belgium."
No. Yes.
Hello, Devoxx Belgium.
You have not clicked.
Sorry. No. Hello, the Bucks. Excuse me for my accent. I will say a color. It's easier. Blue.
You click.
Oh. Sorry. He recognizes what I said. I will say it's easier blue. So actually it works. Sorry about that. I guess it's the demo effect, I guess. We can also use the vibration. I don't know if you
heard it? No.
No. Okay. There are many other cool stuff that we can only use. We can only have with only JavaScript and HTML and maybe a bit of CSS.
You have the shake.
The shake also. I shake the phone and it change the color. Maybe sometime to reload or do some stuff, maybe the feature of shaking your phone is really useful.
If your user is nervous, maybe it can use case.
Well, he's about to throw his phone, so no, don't throw it. So that's it for the showcase. Now we are going back to the application, to the presentation. Sorry.
As Fedi said, we can deal with device state. You have now information about your connection, if you are on 3G or something like that. You can now, if you are online or offline, the battery status is deprecated. I think it's available only on Chrome. I think you can play with vibration. Why not? You can deal with sensors too, like GPS or camera or microphone. You can have information about position of your device, of your motion. but there is a lot of capabilities, and every year a browser know new things, and it can handle the new features. Actually, main browser knows notification. It can handle push messages, the foreground detection, or something like that. The browser can handle storage. Every knows local storage, I think, but there is 3 standards. You have the web storage. It's a key value string store. So you have the local storage or the session storage. You have the IndexedDB. It's newer than previous storage. It's a database-like structure. So you have index or a transaction as any DB.
We actually prepared a little presentation for a little showcase for IndexedDB, but we will not show it to on the mobile device because the interesting part is the dev tools of our browser, so we can see what we actually write on the database. So it's an offline storage. No, that's not it.
No, you are localhost.
So
and you have the last version, I think.
Okay. No. Guillaume.
It's me.
Okay.
IndexedDB.
No, IndexedDB. So we will say Fedi Salah, and I will submit. The user has been added. Guillaume Salah. We are going to keep the same name.
We are brother.
It might seem obvious. So
it's clear for the console?
do we have to zoom or not? Okay, thank you. Now we will see here in storage under the subsection IndexedDB, we will see the name of our database. We named it demo Devoxx database, and now in the database we have created a table called persons, and in which we put an ID, and that's the value.
The ID is just a timestamp.
Yes.
It's not a patent.
We can also use auto-generated ID with just writing ++ in front of ID, and it will auto-generate itself like the next value. We see our users that we have created. We can also make search, like we can. It's really actually like a relational database with transactions and with join and stuff like that. So when we say Salah and we search, I find Guillaume Salah. That's why I kept the same name, so we see that it actually may return more than one result.
And if you refresh the page,
when we refresh the page,
idea.
Yes, that's the last added. It's persistent. It's really saved on the browser. And one thing that you should know also is that once you use IndexedDB, for example, on an app, and the app is installed on your mobile device, it will be stored with the app. It will not be stored only in the browser. But we will see that in more detail further. So.
Okay, so we have just seen IndexedDB. You have a third storage type. It's the cache API, where you can store request-response pairs. It's useful for service worker. We will see later. To handle this different storage, there are some libs as a local forage, but for example, it's an abstraction of the different storage. So if your user, your browser, doesn't handle IndexedDB, this lib fall back to local storage or other.
Yes. If I may add something also, when you use this kind of APIs, don't forget to check if actually your browser supports this implementation, because these implementations are really recent and only the latest version of some browser are implementing these APIs. So we highly recommend you to check if the API does exist and then use it.
About storage, so you can store everything you want, but not all the world. There is quota, but the rules are not the same. It depends on the browser and OS. For example, for Chrome, you have about 6% of the remaining free space. After UX considerations, you have UI considerations too. So to do that, you must master CSS. We are not master on CSS, as you can see on the showcase. But if you want to have a well application and display very well on the smartphone, hire a person who really knows CSS. It's a really job, and it's not.
It's not ours. we actually work with people who master CSS, and they does an awesome job. But it's really a job for people who know how to do CSS. It's not for a JavaScript developer.
Your application must be fit with different screen size. Your application is a web app, so it can display on a desktop. You have tablet too, and of course mobile. But on mobile you have iPhone 5 and now iPhone X. But the screens are not the same size. But your application must have a well display on each size. The responsiveness is a web core feature since many years now. Everybody knows media queries or Flexbox maybe, but there is a resize observer too. It's a JS where it observes if the size of screen is changed or if you resize your window or something like that. Twitter use a resize observer for its mobile website, mobile.twitter.com, and in their CSS for this website there is 0 media queries. All is with the resize observer. It renders a different tree of components. Depends on the screen size. Good to know too, Google mainly use a mobile version for its indexation. So if you want a good ranking, make a responsive app. Second point to implement, it's HTTPS. HTTPS it's mandatory for a lot of HTML5 APIs, especially for service worker. So your application must be served over HTTPS. Third point, your application must have initial page load very fast. As we can see previous, the fastness is important. So you must do the job. Google has defined application shell notion. So the application shell is a minimal HTML, CSS, and JavaScript required to power the skeleton. It means that you have on the screen you have many blocks. Sorry, with you have the header, you have the menu, and when the dynamic content is loaded, this content come into the blocks. In the real application, here it's george.com or .uk. I don't think. You can see the different blocks where when the data are loaded, the picture or come into the block.
It's a sort of placeholder for the pictures. So you can have like the side of the page and how the data will be displayed, and then when the data are there, the display of the data will be smooth. So you don't have a blank screen or something, and then you display on one shot all the screen.
Your application must load fast. To do that, use as little data as possible, and use static assets from a local cache to speed up the first load. To improve page load, you have many tips. First, client side, use light assets and especially dedicated assets. HTML. In HTML, you have the image tag where you have the src set attribute where you can set different URL for different screen. Use it. Your browser is smart and it chooses the right URL for the screen. It's obvious, but declare only needed JS and CSS on the page. Your application need jQuery maybe, but on other page, maybe it's not need to have the indicator on the home page. In the same way, remove unneeded CSS rules or dead code. Otherwise, your files are too big and it's slow to load. And in your build phase, think to minify your script and CSS. Second point, to server-side considerations, you can have mobile API. It's a good practice to have this type of API. So do it and think about what you want to display. It's not needed to have all the document of your database if you are only display two fields. Then use a compressed mechanism of your server. All server know that now. Do HTTP caching, and if you can, use HTTP2. Fourth point, you must have the prompt add to home screen. So to do that, you must have a manifest file. A manifest file is like identity of your application. Here it's manifest file for Twitter PWA. On this file, we can see many keys. You have the name, of course. You have an icon set, theme color, or display mode, or something like that, and start URLs too. And you have on the right, you have the prompt which displays with the icon that you set in this file. When you click on the Add to Home Screen, you have the icon on your home screen with the icon you define in the file. And when you click on it, you have first the splash screen with the theme colors from the manifest file again. And when the application is launched, it's launched in the full screen. You have no URL bar. It's like a native app. This manifest must be linked in HTML page header, just like that. Some precisions or recommendations for the manifest file. The key short name must be 12 characters length max. It's a recommendation from Google, so do it if you can. The scope key means it's a set of URLs that the browser considers to be within in the app, and of course, start URL must be in the scope. This is the list of the criteria for have the add to home screen prompt. First, your progressive web app is not always installed. Okay. Your application is served over HTTPS. You have a manifest file with some keys, and especially specific size for icons. And you have you must have a service worker which can handle fetch event. For iOS, there is some specificities because iOS doesn't handle add to home screen yet. So there is an alternative. You can add this meta in your header to have an icon shortcut, to have a launch screen, to have a standalone mode or other. And when all these criteria are met, this add to home screen prompt can be shown. On Android, it's automatic. It's called mini info bar. You have it's on the left. For Firefox, you have the house icon with a plus inside, and when you click on it, you have the prompt, and you can add then the application to the home screen. On iOS, you must go to the browser settings to add the current page to your home screen. It's like a shortcut. This prompt comes with a different event that you can listen. There is before install prompt. This event is fired when the criteria are met. You can prevent this event to show the prompt later, but this prompt can be shown once time. In previous version Chrome, you can prevent and show this prompt later, but since the Chrome implement mini info bar, you can't. You have to the app installed event. It's fired when the user accepts the prompt and app is successfully added to the home screen. You can listen this event for some stats or whatever. When the application is installed on Android, there is a web APK which is generated. This APK is based on a manifest file and enforce the native app behavior. You have an install notion or information about storage or about battery as an
ordinary app.
Maybe you want to show it or not?
No,
okay.
We will show it later in the demo where we will build a whole a complete progressive web app from scratch. So.
And last point, you must handle the offline. So.
Thank you. So when we talk about offline and web, it's really the first thing that we think of, that offline and web, there are two things that cannot go together, since the web is based on a client-server architecture. So when the server is not there, the client won't reach the server, so it won't display any content. So how exactly do we manage the offline? So let's imagine that we have a man in the middle between, like, not a security issue or something like that, but a man in the middle between the client and the server. And this man in the middle, let's call it proxy for to avoid the trouble. So this proxy can handle all the requests from the client and then manages them. So it will call the server, get the response, maybe store the response somewhere, and respond to the client. And maybe when the server is not reachable, this proxy can send the stored response instead of the actual response. And so that's what we call a service worker. So what is a service worker? A service worker is a web worker. A web worker, it's an API that was provided recently, implemented recently by for example, Safari, and it was implemented already since the 50th version of Chrome or something. I don't remember exactly, but the most important thing to know about web worker is that it's running on a background in a side thread. It's not blocking, and it has no access to the DOM. So when we imagine that our application will do a lot of intensive calculations, stuff like that, we can use a web worker to do this calculation without really freezing our UI. And since it's an apart thread and it's not blocking, it's really kind of the best use case for that. So we do the calculation in another thread, and when the other thread complete the calculation, it can send us the response. And the communication between client and what we call client is the tab or the UI threads. The communication between client and web workers go through the API post message. So a service worker needs also HTTPS to work. It's based on asynchronous call, it's non-blocking, and it's also event-driven. We fire events, and the service worker define handlers for this kind of events. So let's see what happens when our application, the code of our application is executed on the browser. First, and the main thread will test if, of course, if the service worker is supported by another navigator. If it's the case, we are going to register the service worker. The service worker will be registered. After that, an event will be fired. It's the install event. The service worker will be installed. Once it's installed, it will fire an activate event. And once the activate event has been fired, the service worker will take the control of the page where the registration has been done, and then we can call that the page is controlled. What we call controlled here is that all the fetches that are made from this page will pass through the service worker. When we see code, it's pretty simple. Actually, we use the API service worker, and we use service worker and the API register to register the URL. We can also define a scope. A scope for when we register a service worker, we may actually don't want the service worker to control the whole pages. We want it to control only a subsection of our pages, so we can define a sort of scope. Here we see an example. In the first case, the scope was /, so the service worker will handle index HTML, full HTML. It will not handle other HTML because when the scope is /, the default scope of the service worker is the directory where the service worker is written. So in this case, it's not in the same directory, so it won't be handled by the service worker. And when we register the scope foo, the service worker will handle only foo.html. When you implement the code and the service worker won't work, actually it's one of these main three reasons. Either your application is not over HTTPS, or the service worker path is wrong, or the origin is not this. The origin of your application and the service worker are not the same, so the registration will fail. Otherwise, it will go well. Once a service worker is registered, we talked about an install event that will be fired. This is the first event that's fired after the registration. And there we can create the cache. We can imagine that we will put all the static asset of our website in the cache. And so the next time when reload our page, we don't actually need to contact the server to get these assets. We are going only to use the cache API and fetch the data from the cache, and we will actually we will improve our performance since the cache is right there, so it won't take a while to respond.
It's the right place to store to cache your application shell, for example.
Yes. So when we see the code, we listen to the event install, we open, we use the cache API, we open the cache. The best practice to do here is to name your cache. So if you have multiple applications on the same origin, each application will have its own cache because the cache is unique per origin. So the best recommendation is to name your cache. And here in this case, we will use the cache API to store the request response pair. We see here in the code the wait until. The wait until is when we will say, when this code will be executed, the install event will finish. So the activate event will be triggered after the install event. So we use wait until to actually wait for the promise inside the wait until to be resolved. In that case, the promise returned by cache add all. Once it's resolved, the wait until it will be resolved too. So the activate event will take place after the install event. When the activate event will be fired, so it means that we provide a new implementation of the service either for the first time, so we activate for the first time the service worker, or on the next time when we change the implementation of the service worker, the install event will be triggered and the activate event will be triggered again. So since it's a newer version, it might be the good place to remove the previous cache, and because the implementation had changed, so maybe the static assets has changed, so it's kind of the right place to remove this previous version of the assets, and for the next and let, for example, the fetch call the server and get the latest snapshot of our data and refill the cache again. And here we say that the cache API is origin storage. That's why I recommended you earlier to use names for each application, and for each cache.
The cache is independent from the browser cache, and
yes,
it's persistent too.
It's persistent, it's independent, so when you clear your browser cache, don't worry, your application will still work. All the data you cached will still be there. So here is an example for activate. The same way we will wait until, we will wait until we fetch all the keys from the cache, we delete all the keys, and maybe we can have a sort of a whitelist that maybe, I don't know, the background image do not change on every build, so we will keep it on a whitelist and we will never wipe it from the cache. So that's an example. For our example, on the next part of the presentation, you will see that we will have all the icons. We put all the icons in this whitelist, so the icons won't be removed from the cache to be re-put again, because we won't change icon. Once the service worker is activated, the service worker will control the page, will have the control over the page only when we either we will refresh our page and the service worker will take the control of the page, or we can also call an API called client.claim, and this API says that the newer version of the service worker will take the control of the page, so we don't need a refresh. We actually prepared a demo for that, and we'll see more detail just a few minutes later. So on first installation, we are going to install the service worker pass from installing to activating. So how about update now? When we update a newer version of, when we push a newer version of our service worker, the install event will be fired again, and the activate event will be fired again as well. But to make the next implementation of the service worker take control of the pages, we can have we have two choices. Either we will kill all the clients, so the previous version of the service worker won't control any client, so it can be removed and replaced by the newer version, or we can have also an API called skip waiting for that. So actually this API is very useful because we will not ask our user every time to kill his app because we actually uploaded a newer version of our app. So the skip waiting might do the trick, and it works smooth. So we have also a a demo for that, just in a few minutes. So that's the use case of the skip waiting. But also, maybe if you change the implementation of the service worker, how fetch are handled or stuff like that. So the newer version and the previous version won't be compatible. So we cannot have to use this skip waiting with caution. Sometimes the best way is to force to kill all the client, so the service worker will work. The newer version of service worker will work with the newer version of clients. So sometimes we don't have a choice, but on most of the time, skip waiting can do the trick for us. And on update, so we will install the newer version will be installed, and it will pass to waiting phase. And after, either we call skip waiting or we close all the tabs, and after that we will the newer version will be active and it will control the page. So this is the demo. Guillaume will show you how exactly the claim and the skip waiting works.
So on the same application as our showcase. So where is my page here? Okay, it's on local. It's here. This is these links. So I have my code up here. This is the first sample. So I have a HTML page with very useless information, but the important part is here. We upload an image after 3 seconds. Why? It's to be sure that the service worker is fully successful installed. Here you have the registration of the service worker, and service worker. We have the install event handler, the same for activate with a specific log, and the fetch handler just display a log. So show me the console. Okay, I click on it. We've seen the different event: install, where we're caching assets, the activate event. But the service worker is installed, it's okay. But the fetch log, this log, is not displayed. Is not displayed. Whereas the image load 3 seconds after. To have the fetch log, I refresh my page, and that's it. Okay. In this implementation, we don't use client's claims, so we'll see in the next demo the benefits of this instruction. So we have the same page with the same elements, with our picture loaded after 3 seconds. in our service worker, you can see the client's claim instruction here. So go to the demo. Hop. Up. So what's happened? There is event install, activate, and the other. There is no fetch for the first asset, but for the last image, you can see the fetch log. It's due to the client's claim, where with this instruction, service worker can handle immediately the fetch event.
Without need to refresh the page.
Yes.
So that's the showcase. What's
so what about if I update my service worker? So be crazy. Woo. I refresh my page. The fetch is always the same. It shows me that new content is available. If I go to the application tab, we have our service worker here. It tells us we have a new service worker, but it's in the waiting phase. If I refresh the page, I have always the older version. If I skip waiting, okay, I have the activate event log, and the new version is now available. Okay. To avoid to do that, we have the skip waiting instruction, as said Fedi just before.
We actually did it from the dev tools. Otherwise, we should have to kill actually the tab and relaunch our browser, and that's when the newer version of the service worker would take place. So with the skip waiting, we avoid asking our user to do that.
In our last samples, we have always the same HTML page with image loaded after 3 seconds. And in our implementation of service worker, we have just the skip waiting event, not the client claim, so be careful. But you can
combine both.
Yes. And we have a log, so I go to my demo. Okay. So we have no fetch log because we have we don't have the client's claim instruction. If I refresh my page, it's okay. OPP. And if I update my service worker, I refresh my page. I have the previous fetch log, but for my picture loaded after 3 seconds, my service worker with the skip waiting instruction had activate install, so it can handle fetch event, and we have the new version of on our service worker.
Yes, because the image is loaded 3 seconds later, so the time this newer version of the service worker had take place. So that's why we see the fetch with the updated log.
So okay, back to the slide. Maybe okay. So a little summary about service worker state. So we have seen there is installing state. It means the install event has been fired, but is not complete. You have the installed state 2, then. It's when the install phase is complete, and the service worker has finished its setup. Then you have the activating state. At this point, the activate event has been fired, but not yet complete. Then the activated state, your service worker is fully active and can now handle functional events as a fetch. You have two, you can see on the Chrome DevTools, your service worker is redundant. It means it's an older version, or there is a failed install. So your service worker, after the activate phase, can handle functional events as a fetch, sync, or push. So for the fetch event, this is the main event, I think, in progressive web app. This event is fired for each request which goes through the network. This handler catch this request, and depending on the cache strategies implemented, it look up into the cache if there is an existing response for this request, or making this request over the network. And it can put the response into the cache. In code, it's like this. We can see in these strategies we look up first into the cache, and in some case of failure, we make the real request over the network. And in both cases, we put the response into the cache for the next call. You can see on the last line, we send a clone of the response. It's because the response has been consumed. So if you just return the response, you have an error. So we are many strategies. You can mix strategies in your fetch handler. It depends on URL you handle. There is first the cache-only strategies. The service worker look up only into the cache. It makes no request over the network. It's useful for static assets of the application shell, for example. In the same way, you have the network only, where the service worker make up only request over the network. It don't look up from the cache. Yes, it's useful for analytics request or for post request, where it has no sense to store a response for an analytics request. You have the caching first strategy. If you want to build an offline first application, you can do that frequently. The service worker look up into the cache first and fall back to the network if the response is not in the cache, or if some failure occurs, and then the response is sent back to the page. You have in the same way the network first, where the service worker make first the real request over the network, and in case of failure, it look up into the cache, then the response is sent back to the page. It's useful for avatars, for example, which can be updated frequently. So we look up into the cache first for to check if it has new version, or if it has no connection or poor connection. It look up into the cache. With this strategy, be careful to the network speed, because it take time to make a request depending your connection speed. You have the stale while revalidate strategy. The service worker look up into the cache, then send back a response to have fast response and a fast display. But in the same time, it makes the request over the network. When the network responds, the response is put into the cache for the next call. But here, when the response come, you can alert your user that there is new data available. This strategies cache then network is almost same as the previous, except it's the page itself we
request the cache.
Yes, and do the real request over the networks in the same time. In this strategy, the network response is put into the cache, but it's sent to the page too. It's for example, the Twitter strategies to display new tweets available. With these strategies, be careful, don't delete an element with which a user interacted with.
So here we will give you a 20 minutes break, and for the next part of this session we will explain more usage of use cases of the service worker, and then we will build an app from scratch. We will implement the install, activate event, the fetch, and maybe background sync for
real code.
Yes.
So
see you in 20 minutes. Thank you. Thank you for coming back. So we saw previously the interesting part about service worker. When service worker, we can implement actually the listener of the fetch event, and then we can put the request and the response in cache, and our application can prompt us first to install it in our to have a shortcut in our home screen, and then it can also work on offline depending on the strategy that we have implemented. So other use case of the service worker is the push notification. We saw previously that push notification are pretty important for the engaging aspect of our application. So when we talk about the push notification, actually this is the life cycle of a push message. The push server will send a notification. It got intercepted by the service worker, and then the service worker will display the notification, and maybe during the display of the notification, the service worker can do other stuff like reload the cache or call a HTTP request for some kind of reasons. We can imagine a lot of stuff that may be synchronizing data or stuff like that, but we have to be careful with the battery, since the service worker, it runs on an apart thread, just beside our application, so it cannot run in background. So when we are not using your app, actually the server worker is still working. So if we do intensive HTTP calls, our battery might die because the service worker is still working and it's using a lot of resources. So it's an API called push event, and when we show the notification, we will use the show notification of the object registration, actually the object that we get when the service worker is registered. And when we receive a message from the server, we will display the notification, so we will improve our engagement aspect of our application. So when we see the life cycle of, sorry, we did not put it in full screen. Sorry about that.
Beautiful animation.
Yes. Yeah. Now, the service worker will be registered. After the service worker got registered, we will subscribe to a third-party push server, and this server will send us a subscription. We can store the subscription object to our application server, and then for some reason we ask our application server to send a notification. Then this application server will use the subscription and send it to the push server, and this elder will send the notification, and it got intercepted by the service worker, and the service worker will do stuff and display it, or just display it. It depends really on our implementation. So when we see the code, sorry, when the service worker is registered, on the registration object, we will have the push manager API, and then we will subscribe. Of course, we will ask the user if he authorized the application to send in notification. If the user will accept this. So this promise will be resolved, and then we will have the subscription object, and then we store the subscription object in our application server, and then we will ask our application server to send a notification, and the application server will ask the push server to send the notification, and the service worker will intercept the notification. And that's the code that we write on the service worker. We will listen on the push event, and when we get the notification, this event will be fired, and now the implementation, we will show a notification like that by using the show notification API. Other than push notification, there is also local notification. We don't need actually a third-party push server to send us a notification. We just our application will just show a notification. Maybe it's useful for some reminders or stuff like that, or I don't know, maybe some other use case. But the thing to learn is that with the registration, we can directly call the show notification API, and we can put the title of the notification, the body. We can use also the vibrate for like 300 milliseconds. We can display an icon, we can display data, stuff like that. So this picture will show us how can we customize a progressive web app, that a notification that is in our showcase, and the notification will display like this. We customize the icon, it's the body, the image, the badge, and the title. We can also define action on the notification. If we will ask users questions or stuff like that, we will actually we can actually define some actions, and when these actions are clicked, we can handle the click of the notification. This code is has to be written on the server the service worker part, and when we click, for example, on a notification, we can iterate over all the clients controlled by the service worker, and maybe open a new window on this URL, or navigate to a specific URL from our client, or maybe we can do deep linking too. From notification, we can go inside a specific content of our application.
On this sample, you can see we play with data that we can send here. Yeah, you can retrieve this data to do stuff for you and for your application. So
we see that a service worker can be useful for notification, to send notification to our users, but the other use case, which is pretty important, is which is as important as notification, is background synchronization. What do we mean by background synchronization? When we talked earlier about progressive web app, we talk about mobile first, and there is also another notion that's called offline first. We may think our application as an offline first application, so all the data all the action made by the user will be stored locally and then synced to the server. So the user can actually use his app while his app is offline, and then when the network state will change, the service worker will automatically fires events to synchronize synchronize event, and in the implementation of the synchronized event, we can like read the data, the locally stored data, and synchronize it with the server. So it's kind of offline first pattern, and it's very useful in some cases. So on change of the network, as we said, we have to fetch the local data and send it to the data. Maybe update UI to say your data has been synced or stuff like that. So when we talk code, to register for the background sync, everything happens on the registration object. We have an API called sync, and we call the register method on this API, and we can actually define a tag of a specific event, and then this code we have to write in our page, and then on the service worker we have to listen, just like notification, we have to listen to the event called sync and test about our tag, and if is our tag, we will wait until we can do some stuff, and so some stuff would be fetch local data and send it to the server, and maybe do other stuff after that, like updating cache or displaying stuff to the user. It really depends on our implementation. So for the demo, we did prepare you an application. It's you can check this URL, and it's a kind of social network about beers. We came to Belgium, we like beers, so we said, let's do a social network about beers. So the code is available on this link. The latest version of it's available also of the other link, but we're not quite sure that it's the latest version, but the latest version is available on this link. So to remember that alcohol is not good for health, so
be careful.
Be careful with alcohol. So the application we built provides some basic feature. We list all the posts. We can create a user, log into our application, maybe favorite some posts, thumb up and thumb down some posts, comment a post, add a new post, and synchronize data with in the background.
Yes, we want that the application works offline,
right.
Like a charm.
Yes, it's designed offline first. Actually, you will see that in a moment. So here's an example of the screen. There's a post. We have a list of action. There's an example of a notification here. The architecture we did use. Actually, we built this a progressive web app, but we also use the opportunity to test some cool technology like Firestore or cloud storage or Google Cloud Function. Actually, our server is deployed on a function as a service provided by Google, and it interacts with Firestore for storing the data, and cloud storage for buckets, and where we will store images. We also use a new draft called Web Push Draft to provide us a service to send us notification. And we also use IndexedDB in client side, and also CacheDB. We use also React to build the UI.
You can use other providers. We are not sponsored by Google.
Yes,
but,
we just really, for the demo, it's really cool to deploy like instantly the new version of the code, and that's why we use this kind of technology. So let's go to the demo. For the demo, we'll go to, this is the website. We're gonna have a tour. I'm not logged in, so I can see only the post. I cannot make any action about the post. So I have to log in. So here I am a user. I list my posts. I did not favorite. I can favorite a post. I can favorite another one. And now we see both favorite posts are displayed. we did not see any notification. So let's see, this is the detail of a post with a comment. There is actually a user who wrote this comment. Thank you. I don't understand a bit what's written, but thank you. So we also, you see, there's some of you who had actually add a new post, and we actually see the new post here, and we click on it, and we see the new post. Thank you. Yeah. Thank you, guest. Or I don't know, but thank you. So our application actually works. So let's.
Maybe you can create a new post.
Yes. Let's see when we create another post, like Guillaume said, what happens. Actually, I will create a new post for demo. This is also the permission that we talked about earlier. Our application asks us if we allow it to use the camera. So for the demo, we will allow it. We'll take a picture as speakers. It's not about beer this time. Yeah. We can also use geolocalizations. Sometimes it did work. So
you're lucky.
It did not ask us because I already approved this application to use our the geolocalization. Now I will add the post. You see, the post is actually there is an opacity over the post. It means that the post is actually saved locally, and then when it got synced, it changed the color. So actually, when if I stop network, like on offline, we have a banner that will show us, which is a good practice to alert the user that his connection state has changed. Now we also we see the content even when we don't have network. We'll say also the content, sorry, and
try to
yes,
add favorite your post, or
I will comment this post, for example. This is a new comment. The comment is actually, there is an opacity of it means that the comment is locally registered. Only me as the creator of the comment who can see this comment, because it's not synced on the server, and it did not get synced because we don't have actually internet connection. Now
clear your console.
I will clear my console here, and just by changing the state of connection, you are online, we are syncing comment, and the comment gets synced by itself, which is pretty great. So when you can provide a offline user experience of offline first application, which really does work. You don't need to do anything other than coding properly, and the application will work offline, online when the internet state will change, and the application will does what it's supposed to does, what it's supposed to do. Sorry. Without triggering manually any event or any code. So we do
you want a notification? Maybe.
Yes, I can favorite. I did receive a notification. There is a user who created a post, and he voted up my post. We see here. He favorites my post also. We see only what we favorite us, so that's why I don't see the heart here, but okay. Our application is working, and we saw that the application works even on offline mode, and it gets synchronized by itself when the internet the connection state changes. So now for the demo, we did create another application that's basically the same. Sorry. It is just
write it.
Sorry. Dash demo. So
this is fake data.
This is fake data. We injected mock data so we can. When we see our application and we put, for example, offline mode, our application won't work, of course. And on mobile, if we visit this website, it won't prompt us. And if we see on the DevTool here, we don't have a manifest or we don't have a service worker. We don't. We actually do have IndexedDB since it's not already installed because when it got installed, when actually we will store data in IndexedDB, that's when the database will be created. I can log in if we want. I created a user. So IndexedDB is now created, and we have table called comments, posts, notification, favorites, votes. All data are empty. I can use it offline because I don't need actually a service worker, so IndexedDB will work. IndexedDB is an HTML5 API, so I can use it. I can favorite a post and go here and see my favorited post. But if I add comments or add posts, all posts and comments will have the opacity because it won't get synced to the server since the implementation is not quite there yet. So let's see the code that we have to write and to implement this kind of features, and so the application will prompt us to install to get installed on our device. So now the first thing is to create a manifest file in the public. This is the public device where our page index.html is provided. So I will create a manifest. JSON. I create a snippet, otherwise it will get so long to write every step. So here we will comment every snippet we use. Here we write the name of the application, the sort name, the display mode. Is it standalone? Is it full screen? Is it browser? I guess the other. I guess. To have a URL, the theme color, the background color, the orientation. Here is a set of icons for every device.
You have an online tool where you put your just an icon, your title and your colors, and it build for you the manifest file with all the picture with the good size.
Yes. Speaking of tools, actually we have also a pretty cool tool that will audit our application and says if it's you have some performance issues or your application is not good at your SEO of your application is not good enough, or if your application is progressive or not. The tool is called Lighthouse, and now in performance we're good. We have like 79%. Progressive web app we are 58. Accessibility not that good. Best practices we write good code, that's great. SEO is 80. It's not that bad actually. But the interesting part about Lighthouse is that it gives you a hint here. So for progressive web app, so it does not respond within 200 it does not respond to 100 when offline, so it on contradiction of a progressive web app principle. Start URL does not respond to 100. Does not register a service worker. User will not be prompted to install web app. And now failures no manifest what fetch, and site does not register a service worker. And that earlier we had a question about if without the service worker we can have the prompt, and now we see that Lighthouse told us to be prompt by the application. We have at least to implement manifest and a service worker.
And you have some links to help you.
Yes, you have some learn more, and then you learn more about progressive web app and how to make it work properly. So now we go back to our code. We did create manifest.json. We will link it to our page here.
No.
Without the dot, sorry.
Close the tag, maybe.
Yes, it's better. So we are also going to create an empty service worker. So service-worker.js.
Yes.
We are going to listen only to fetch. So we implement self that add.
Your service worker must listen fetch.
Sorry.
With a D.
Yes, thank you. Because I have a back pain actually. Sorry. Fetch and so now we have to register the service worker. So for that we will add here on our JavaScript, we'll add a new file called service worker. Actually, we call it service worker, but it's just the registration of the service worker. It might confuse you, but it's not the service worker, it's just the registration of the service worker. So for this, I have register. So first we check if service worker exists in our navigator. If it's the case, on load of our page, we will register the service worker. We give the URL. So since we create the service worker on the public here, so the service worker will have the scope, all the scope here. Actually, we write code and it will be compiled and all will be put in the public folder. So the service worker will have the scope on all of our application. So in the register service worker, we call the API register. Once we get the registration object, we will override actually the update found to handle updates. When service worker will change, what will we do? So we will test the state of the service worker if it's already installed. If it has the control of the application, it means that the install phase had passed and the activate phase 2. So here at this point, we said earlier that after inside the activation, it's the newer version of the service worker will take control over the new app. So at this point, it will be the best time to clear the previous version of the cache. And if it's not controlled, if it's just installed, so in the else part, we know that the install part had passed, so our service worker, our cache, our assets are already in the cache, and we we may say something about that on the user. So we actually define two callbacks on the config which we pass to the register method, and if we override them, we will we know that code will be executed on update after the activation of the newer version of the service worker, and the unsuccess after the installation of the service worker. This might be useful because when we have a newer version of the service worker, we may push the user to refresh his page, so the newer version will take control, and we will see new data, new snapshot of the data. So here we have to
call the registration.
Yes, we have to call the registration. Import star as from register, and we are going to override on update just to display a little button on which we click, and the page will be refreshed. Or we can also do the pull to refresh, but it's easier to tell the user that there is a newer version of the service worker and he has to update his page. It's just an refresh. It's as simple as that. Sorry, update. I use arrow functions, so it's simpler to write. So here, document. I know that I have an element called
in our client-side code. We have an element with ID new version, which is on the page, but with a style inline in display none.
Yes, that's why we told you to hire really a CSS expert, but it's not the best way to display stuff in CSS here. So we use style nothing. So
it does the job.
Yes, but it's not a bad practice. So now the service worker is registered. The manifest file is here. We will deploy the newer version of our code. Yeah, we will build, so we will have the newer version of our JS, and then we will deploy with the newer version of the service worker.
Come on.
Sorry about that. I'm not supposed to say that. See that? We will show you on a real phone how the application will behave when we visit the website. So sorry. Deploy.
Try Firebase, maybe.
Sorry, it's not yarn. Yes. So we actually see. This is the application that we have installed. It's not the demo application, that's the real application. No, we will wait until the deployment is successful. I did not need to deploy functions because function did not move. Just it depends on internet speed. So sorry about that. Next time we won't be deploying function because function is the server side code, and the server side code did not move. So now releasing newer version, so it's okay. Now let's see here.
This is here.
Yes, this is our application. It loads the data, And now it prompts us add Airbnb demo to home screen. So what? Now it prompts us like this. We will add it. And now it's added to our home screen, and we can kill the other app, and
it's
here. It displays on display mode, and for first load we don't have cache, so it will actually call the server, and that's why it was a bit slow. We can see also that we see it in the list of our application. Guillaume will show us too.
We'll see the first application. Maybe this is the first or the second, I don't know. But it's like my Chrome application, for example.
We can click on the application, so we can uninstall it or edit or app info.
But yes, storage or something like that.
We can clear the data. Actually, the store of the application is really independent. It's not the store of the browser. It's store for the application.
Okay.
So let's go to the next part then.
So we have an app with we have a progressive web app.
Yes.
Maybe you can run Lighthouse.
Yes. We will run it. Yes, okay. We'll run it at the end.
Okay.
Because I guess it may take a little time, and we have only 49 minutes left. So now we will implement the offline support of our application. So when we actually when we don't have network, our application will respond with the cache. So for this, we are going to define a cache equal air, beer, and beer. Sorry.
Well, it's just a name.
Cache. We prepared pre-cache.
Yes. First.
Yes. This is the list of assets that we will put on the install. We have also prepared a list of assets that when we build a newer version of the service worker, we will remove this cache and replace it by the newer version assets. So for this, we will need to.
It's not the smartest strategy.
So now
there is some tools that handle this updates more smart.
Yes. For this demo, we will implement the service worker from scratch. But in real life, there is plugin that does the job for us, and it will handle it properly, and we can define actually a kind of router or stuff like that. Depending on each URL, we can define our cache strategy and stuff like that. We will say later there is a two
Webpack plugin.
Yes, two Webpack plugin that we can use. So here we see that we install. On install, we will wait until the event the promise inside the event get resolved, and we will open our cache, and we will add our pre-cache file. And after that, don't forget the skip waiting. Activate. On activate 2, we read our cache, and if the request if the request already in cache matches with this URL, we will remove the cache. So we know on daily basis when we provide a newer version of the service worker, it means that our code, we have a newer version of our code, so our CSS and our JS had moved on our index HTML, so we have actually to remove them from the cache on the activation of the newer version of the service worker. And now we will implement the same here, but we will listen to fetch.
Be careful, you have the last line.
Sorry, we have already fetched, sorry. So we will add here event, and here we will HTTP get. Also, we fetch only we store in the cache only the GET request. The POST request, it doesn't make much sense to store a POST request. So only the GET request when we are fetching data from the server. So also this same origin. Also this when the server sets this header, it's actually a Chromium bug, so we don't have to lose time explaining this. But when the server sets only if cached, set the cache of the response only if cached, it has to be same origin, otherwise the service worker will display an error. Also here we test over HTTP because sometimes the service worker does requests on a Chrome extension or stuff like that. So we will handle only HTTP requests. So now we will open cache. I will return this.
Event.
Sorry. Yes, it's event that respond with.
With this, you send a custom response.
Yes. So we will open the cache, and when the cache is resolved, so here we will return caches that match our event that request.
So we look up first into the cache.
Const. No, sorry.
No, return. That's good.
Then matching if matching return matching, otherwise we will fetch, we will return fetch event dot request, then
we put the response into the cache for the next call,
and we will return the response too. And we store only good response, so we will test if response, sorry, that okay.
It's a pattern because depending of your strategies, if you don't check if the response is okay, you have always an error, and your application is broke. So.
Request, and then we will be careful. You have to store a clone of the response, otherwise the response is a stream, and the stream is only consumable only once. So if we store the response, actually the response will be consumed by the cache. So that's why we store a clone of the response, not quite the response. So here we did implement a basic strategy. We fetch data from cache, and if we find them, we return them. Otherwise, we can have the call of the server. We can do something more, is like, and here we can return, sorry, return response.
This cache first strategies.
Yes. We can also do stuff like that, like this. Even though the request is matching, we are going to fetch data either way, but we will not return the fetch, so this call won't be blocking. It will be triggered, but it won't be blocking, and when it got the response, we have actually the newer version of the cache, so the next call will have the good response from the cache. I guess we finished the implementation of our fetch. We are missing something here.
What's wrong?
Actually, it's
not. So maybe this one. Is that close? Okay.
no.
It's maybe here, I think. Check the here. Okay. And
Well, if I remove this,
yes. The on the
thank you.
yeah.
Oh
No.
no,
This is the parenthesis.
quelle parenthèse?
Celle-là.
Faut la fermer?
Yes.
J'ai pas compris.
This. Yeah, you can delete it,
Vas-y.
I think. So. Here. We have that, okay. Okay.
The response missing. So then we will close.
But you don't close the.
So
Hurrah!
thank you. There we go to format. Sorry about that. So now we have implemented our fetch, so we will deploy again. We are not obliged to build because only the service worker had changed. So we will redeploy the newer version, and we will see. We will show you now on a browser how our application will be shown. So demo. Sometimes that happens, so we have to kill Chrome and now open it again.
Maybe clear the data.
I will clear my browsing data. So the service worker got installed, and now when we go offline and we reload the page. No, it did not work. Sorry. We'll see actually the newer version of the service worker. I guess. So yes. That's it. That's the first refresh. Actually, we should display the button that will push us to refresh the page, but we actually did the refresh. So now it's fully supported on offline. And we see that the requests are done either way, but there is no response since we have no internet connection. So now we've implemented the fetch request. Maybe? Yes, thank you. Network. No, okay. It's okay. So after that, we will actually implement the notification support. For that, we have to register, as we said earlier, we have to register to a push service. So here in the source, when the user actually either sign up or log in, and this we will ask the user if he authorized the application to send notification, and he will register for notification. This is the code of register for notification. We see here we have the registration and registration push manager.subscribe. We will subscribe to the push manager. When we get the subscription object, we save the subscription object to our application server, and then we ask our application server to send a notification. So once we register for notification, we will implement the code here to push notification. When we receive a new notification, we will actually save the notification into IndexedDB too. So here we will import the script of IndexedDB, and we will open the database. It's the same schema as we've defined for our for our application. Thank you.
You're welcome.
So we see favorite posts, comments. We open this and we implement the push notification. So we listen on push notification. We will add the notification locally in the database here, and we will iterate over our client, and for each client we will post a message got notification, and we will also show the notification, and this message will will be sent to the client, so the client will display the number of notification he got. But this code is not actually is not necessary. It's just for us to display the number of notification. Otherwise, the only necessary part is here to display the notification.
Be careful, notification doesn't work on private navigation. So
yes. Now also the notification click handler, we will iterate over all the clients, and we find if we find a client that already opened, we will navigate to the URL notifications to display the notification, and if the
and then focus it.
Yes, and then we will focus on the client. Otherwise, if there is no matching client, the notification will open a new client. So on mobile, when we receive the notification and our application is not really launched, when we click on the notification, it will launch our application, and it will go exactly to the URL of the notification. This is the notification support. We will add also the background sync support, and for that we will have to request actually the background sync when we add data to local database. So here we will go to our store on IndexedDB. When we favorite a post, we will add it into IndexedDB, and we have to request synchronization. The same for votes and comments and posts. So here we will just uncomment this code.
You forget here.
2. So here the implementation of the requesting. Actually, we will test if, of course, after the service worker is ready, we will test if the service worker does implement the sync manager. So we will use the sync manager to synchronize, and this is the real implementation of background sync. And for Safari, for example, we don't have background sync, but we can also trigger background sync since the service worker is actually a web worker. So we can send to this web worker a message, and here we can post to the service worker a post message, and on the service worker we can listen either to the sync event or message event, and we can execute the code. So even though some browser does not support background sync, we can implement our own using the aspect, the web broker, the web broker. Sorry, the web worker aspect of the service worker.
This is a progressive part of progressive web apps.
Yes.
You check if an API is available, and if it's not, you have a workaround, or you display the feature. You display the feature is not available, and when your browser will be able to handle this API, your application
will
is
just
already
work.
ready. Yes.
You won't have to update your code or stuff like that. So here, what I just said, we listen on message and we listen on sync, and both execute the same method here. And we will add sync. We will add the background implementation, and this is the background implementation. So for favorite, we will actually read. We used IndexedDB since IndexedDB is both. We can access IndexedDB from the client side and the service worker side. For example, if we used local storage, we cannot access the local storage from service workers. So that's why we did use IndexedDB. And IndexedDB is basically fully supported by all the browsers, even for Safari. So we fetch the data that were not synced, and then we send to our server. And if we have a response, we can update with synced false. Here we can also, on the response, send post a message to our client, so the client will reload the post. That's why earlier we saw that the post had an opacity, and then when it got synced, it got refreshed automatically. So that's why from the service worker we can send message to our client, and we use post message API, and it works. That's how it works. So
the same for the other features.
Yes, same for the other features, and we will actually add, because sometimes when we get newer version of the post, we send the reload post, but we also have to update our cache. So here we update our cache. We actually create a method here to that take a param, it's URL pattern f, and it store the newer response into the cache. So when we synchronize the data to the server, we actually send the data, get the newer response, put the cache, and send a message to our client to tell it to reload data. So when the client will reload data, it will fetch the data from the cache, and the cache has been already updated, so we will have the last snapshot of the data. So now we will deploy. Oh, sorry, we will have to build first.
You updated stores files. Any question about these parts during the deploy? No. Yeah? I don't think.
No. For Windows, I guess we have a store for web apps, but not for Android or for Apple Store or Google Store. No, just a good SEO will do the trick. So here I'm going to log in.
In the latest version?
I'm not sure. Sorry. Did I save all the files? Yes. Sometimes. No, we actually, I don't see the code here.
I think it's when you click on the link into the console, you have something strange behavior.
Okay, well, I will clear my cache to browsing. Sorry. Import scripts is not defined. No, import scripts, it is defined.
Maybe not. It's with Dexy.
So I wrote the implementation here. Actually, earlier I said it might get confusing, but I wrote the implementation when we register the notification. It's
the registration.
Yes. Sorry about that. It's not where we register. It's not even here.
Until the bottom. Yep.
Yes, it's on the service worker. And that's it.
The other, yeah.
That's it.
It's better, I think.
Yes, it will work.
I just refresh into the page. I don't like this link.
Okay.
Try.
We'll clear.
It tells me there is a new version on the on the mobile. I refresh.
Yes, it asked me to allow notification, so we will allow it. And now if I favorite, well, it's not my post, so I will maybe add a new post.
We are private navigation.
Style of no, there is no. Okay, post. Sorry. Take a new post, allow.
It depends on the network. Yeah.
Yes.
Okay, cool.
So it got synced.
Yeah.
There's some error for React, some React error, not. So it got synced. I can favorite my own post, and I will have the notification. This is the notification here, sent. So I can thumbs up.
And you are private window, so you have done the toast display.
Yes. I'm on private window?
Amazing. No?
No.
Ah.
So we have also the notification here of thumbs up. That's it for the demo. So now we're going to go back to our presentation. Sorry. Because I've cleared my sign in another account here.
No, you.
Sorry.
Non plus.
Oh.
And it Android 32.
No?
The other button.
So we have just seen the progressive web app on mobile, but what about desktop? It works too. There is desktop progressive web apps notions. It's supported by the main platforms, Chrome OS, Linux, Windows, and for Mac it's expected for a future version of Chrome, but you can already test it with enabling a specific flag. On Windows, when you install this app is quite a shortcut on your desktop. The app is available on your search menu, and when application is launched, it's launched into app window with your theme color, other stuff. For macOS, it's display. It's available on your launchpad, and when it's launched, you have in the dock at your bottom of your screen.
It looks like an Electron application if you did use Electron or stuff like that. So.
And it runs into app window to a single window with no URL bar. In terms of best practice, we have already said something. First, ask permission when needed. It's painful when you come into a website and it asks permission for geolocation, for notification, for everything. Anybody like this, so ask when only it's needed. Then, second point, display an online/offline status bar to inform your user. With it, it can understand why he can't have some features available. Display too when a new version of your application is available. Fourth point, check if an API is available in current browser. Implementations are different and are not the same in browser, so it's important to do that. Then last point, namespace your cache names and stores. It's very useful when you must clean your cache. In tooling the considerations, we have seen the Chrome Dev tools. It's very useful and mandatory. You can use it to see the service worker state, the store state, and you can use it to plug an Android device and remote debug on it. We have seen Lighthouse. We don't have the time to display the results on your application. We have talked about Webpack plugins. It's SW Precache and Workbox. These plugins allow to, with minimal configuration, it's built a service worker for you. In compatibility terms, as I said, all browsers are not equal. Chrome implements all, okay, but we can see that all majors do the job to implement feature. It's a good point to the future of a progressive web app. On daily basis, it's easy to build an application. We have many resources. For me, the main is developers.google.com, and since yesterday there is web.dev, I think. There is other links to help you to build your service worker with different strategies. And this serviceworker.rs or www.pwabuilder.com. When you test your application, test on really devices with emulators. You can add the right display, and you can see how the device has behaved as real behavior. Behaves with what you have implemented, and you can use remote devices tab as I said. Think to update your service worker when you add new assets, or when you have update an asset, or when you have changed your fetch rules, and think to clear your cache and browser settings. It avoids a lot of troubles. We have built a great application, okay, but it's not very very useful. In real life, there is many success stories. The first, Twitter, with our progressive web app. All indicators are better. Page per session increase, add tweet sense, the bounce rate decrease. And when we compare app size versus progressive app size, PWA wins largely. There is e-commerce website in Nigeria called Konga. In Nigeria, access internet is very expensive, and connection speed is not well. So many users are on 2G, and for Konga, the fastest and reliable are mandatory. With our PWA, our indicators are better too. There is Flipkart. It's a big e-commerce website India, I think, and we can see on the social media that working like a charm even on 2G. So it's better than the native app at Wi-Fi. So it's a very good point. And there is many success stories in different industries in the e-commerce. But you have an application for the channel, for the weather too, and for cosmetics. You have application. Oh, I'm scared. For sports, for what you want.
in summarize, it's turn to Fedi.
Sorry. So to summarize, we saw that progressive web app is actually will prompt the user to when we implement manifest and a light version of the service worker, we have our application will prompt the user, so the user we can add the application to his home screen, and when he launches the app, he will see his splash screen, sorry, instead of a blank screen. So it's the user will have the impression that he's already in the app. So it's a bit reassuring for the user. It's better for the user. It's better user experience actually. We see also that implementing strategy, we can implement different strategies of cache shows, so we can use this cache to display data. Sometimes data are not does not evolve that often, so we can display the previous snapshot of the data, which is the latest snapshot sometimes, and the application will behave normally even when airplane mode or stuff like that. We also saw that it's a good practice to display to the user that he's offline, and maybe put some overlay on the data that so to show the user that he's an offline. Other uses, thanks to the service worker, is the notification support. Thanks to the notification support, we can our application will be more engaging, so we will have more probability that the user will come again on our application and visit the site again. So he will be more reattached to the application. So if progressive web app works smoothly on every device and every browser, we will say that we don't need to code native apps anymore. We just will do only a progressive web app now, but it's not, unfortunately, it's not the real, it's not that simple, because service worker are partially implemented by some browser with the cool HTML APIs. There's a lot of stuff that are accessible, but there is no contact or SMS access, for example. There is no fingerprint or geoforcing. When we talk about native apps, when we deploy a native app on store, actually there is actual human beings who will test the app before it got validated and it will be put on the store. But with progressive web app, since it's built on with web, and since it's deployed on server on the web, we can lose this benefits. So we can provide users some user experience, some heterogeneous user experience. So it maybe can be inconvenient for our users. We also lose also lose the rating and the feedback of the stores, since if we want to our users to give us feedback, we need to develop our own platform of feedback. Sorry, we saw that also a progressive web app can be considered in some cases as a good alternative, because it provides an app-like behavior. It can reach more easily users with a good SEO. User can find your application just on typing 2 or 3 words on the search engine, and they will find your application. So it's more so it's we can reach more users thanks to that. Also, the size of the application is really tiny. The technology we use to build this application is more common than the technology we use to build a mobile app. we know also that Windows has created a store for progressive web app, and actually progressive web app on Edge runs smoothly, and even the application on desktop, it's like an ordinary application on Windows. So we think that progressive web app are the next mobile reference. Now when we develop a website, we think about making it responsive, but we think that maybe we can do more and make our website a progressive web app as well. And for example, when we see a modern JS library like ReactJS or something, they add to their create script a service worker, the installation of the service worker, and they implement the registration also of the service worker. And the service worker, you don't need to think of a mobile application to implement the service worker. Actually, you can implement the service worker even on your website, and you can send also a notification on your website. So we think that you just do it. And for further reading, there is some links, and as we said, we will share you this slide. You follow us on Twitter, and we will tweet the slide when we put them in SlideShare. Other than that, the code is accessible to everyone on our GitHubs. Thank you for your attention. We have 4 minutes left for questions.
Yes.
Not yet. We used SPW precache, which works with the toolbox and the URL, different pattern for caching and stuff, but not workbox yet.
The React script before uses SW precache, but now in last version uses workbox. So we use it
yes.
in few times.
Yes. 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 We can show you that, I guess. Firebase. No. No. No, iOS really they control a lot the version of the browser they install, so you cannot do all the stuff you can do with the browser. Otherwise, you will not use their browser. So it's kind of yes, they push you to use their browsers, and they don't let the latest update of the other browser. You don't have the add to home screen. You have it on Safari with the specific links we specified, but we don't have it. Not the prompt.
Not the prompt.
Not the prompt.
Yeah.
Yeah. But we did implement actually something cool with even the pull to refresh and stuff. For I have an iPhone, and it works even IndexedDB and background sync without the sync manager, but with the post message, and it works. The only thing that does not work yet is the notification, because they have their own standard. For notification, you have to accept a certificate and stuff like that. It's not really that common that we use that. We thought about doing it, but we said no, we will not do it. So I guess even the notification on Safari work, but with their own standards. We did not test that, but we guess that it will work. Yes, it uses manifest, yes.
Are you sure?
l'icône, il aurait pu être.
For icons, it take information from the header with short icon, splash screen, and so on. Yeah.
Yes.
Yes.
It's
Yes.
a browser API.
On the window.
Yes, it's a browser API. When you use Sync Manager, you don't need to implement, you don't need to listen on the change state, because the Sync Manager actually launches the sync without any implementation needed. It knows that we have the internet has changed. But if we for displaying the banner, if you remember the banner, it's just an API on the navigator. It's online or
Yes.
I don't know.
You listen online or offline events on a window, and that's it. Yes.
Yes.
So it's finished.
Yes. Don't forget to rate us, please. if the talk was great or not. Yeah. Oh, we can talk
we can
all
talk,
day. You know.
after
We
the-
have no problem. But it's not standard. You have to create your own certificate on iTunes Connect, and then you add the certificate to your browser, and so the browser will be known by iTunes Connect, and so the push server will send the notification. It's a bit complicated, so. No. With the Android, no. There is actually a draft that's called Web Push, and the implementation reference is on on npm. It's called Web Push. You can see that, and you generate a couple of VAP ID or something like that, and so your server and your client will know each other, and we will communicate with the subscription. When you when you call push manager dot register or
Subscribe.
subscribe, thank you, you will have the subscription. And now when you send back the subscription to the push manager, it will know that it's you, and you will have he will send you the notification. I don't think so. It's available, but maybe they will check some stuff before, and they will maybe not let it work for some security reasons or something like that. I don't know. I don't really test it.
Yes. Okay. So thank you.
Thank you for your attention.